I was actually staring at my laptop this morning, just looking at that little blinking cursor in
Oh,
ChatGPT.
yeah, the classic blank prompt screen.
Exactly. And I had this sudden realization, we have spent the last 2 years getting really, really good at talking to text boxes.
We have. I
Mhm.
mean, we've all basically become prompt engineers, whether we want to admit it or not.
Right.
We've learned to sort of massage the text and tweak the phrasing, play these little word games to get the machine to do exactly what we want.
We really have, but here's the thing, right? The actual world isn't a text box.
No, it's
The
not.
world is messy. It's visual, it's loud, it has texture and tone and vibes, and that feels like the frustration point we're at right now with AI.
It's a huge bottleneck, yes.
Because you can ask it to write a sonnet and it does it in 3 seconds. But you can't just hold up your phone to your car making a weird grinding noise and say, "Hey, fix this."
Well, not yet.
Right, not
No.
yet.
But that is exactly the cliff edge we are standing on right now. We are moving from this era of just generative AI, which is all about making text and making images, to something called multimodal reasoning.
And that right there is the mission for today's deep dive. We are digging into a fascinating stack of lecture materials from MIT.
From a course titled How to AI Almost Anything.
Yes, specifically a lecture by Paul Yang about recent directions in the field. And honestly, going through these sources, this lecture really feels like a roadmap for how we finally break AI out of that text box.
It really does. Liang's lecture is outlining 3 massive leaps forward.
Okay, let's lay them out for everyone listening.
First, we're going to look at how AI is learning to read vibes, literally detecting things like sarcasm by fusing sight and sound.
Which is mind-blowing.
It is. Second, we're looking at education. There's a tool mentioned called the Interactive Sketchpad that might finally kill the static textbook.
I wish I had that in high school.
Yeah.
And then finally, we are going to talk about agents.
The interactive agents, yeah.
The AI that doesn't just talk to you, but actually takes your digital wallet, goes onto Amazon, and buys you headphones.
Which is incredibly convenient, but also
Absolutely terrifying.
it's a double-edged sword for sure. And it brings up a whole new set of safety and control issues that we need to get into later. Because when AI starts doing things instead of just saying things, the stakes change completely.
They really do. So let's jump right in. Let's start with the vibes.
Multimodal reasoning.
Right. The lecture introduces this concept. Now, to me, multimodal just sounds like tech speak for doing two things at once. Is that fair, or am I oversimplifying that?
It's a good starting point, but it's missing the core nuance. See, right now, most of the AI we interact with is unimodal.
Okay.
You have a model that is an absolute genius at text, like the GPT series. Or you have a completely different model that is a genius at recognizing faces and photos.
But they stay in their lanes.
Exactly. They are siloed experts. They don't cross over.
It's like having a brilliant writer and a brilliant painter in two different rooms, and neither of them has a phone. They can't coordinate.
That is a perfect analogy. They literally don't talk to each other.
Oh.
So multimodal reasoning is about fusion.
Fusion.
Yes, it's about taking the signal from the text and the signal from the image and mashing them together to find a completely new meaning that doesn't exist in either one alone.
It's finding what's between the lines.
Right. It's not just processing 2 separate streams of data. It's understanding the relationship between them.
And the lecture gives this perfect example of why this matters. It's basically the sarcasm test.
I love this example. Sarcasm is notoriously difficult for computers to grasp.
So for you listening, I want you to visualize this specific slide from the source material. There is a photo of 3 people, and honestly, they look miserable.
Very low energy.
Yes, slumped over, eyes half open. They look completely checked out and annoyed. But the text caption right underneath this image reads, quote, "It's just a privilege to watch your mind at work."
Now stop right there and think about the unimodal approach. If you feed just that text sentence into a standard language model, even a really advanced one, what does it see?
Well, it sees a compliment.
Exactly.
It sees words like privilege and mind at work. Those are very positive tokens. So the AI thinks someone is being heavily praised. It analyzes the sentiment as completely positive.
Correct. But if you take just the image and feed it into a facial recognition model, what does that see?
It sees boredom or negative affect.
So you have one model screaming positive sentiment and one model screaming negative sentiment. A unimodal system fails here because it cannot reconcile those two things. It just sees 2 separate facts that contradict each other.
But a human gets it instantly. We look at that and we see the gap.
And that gap is exactly what this new multimodal fusion is looking for. It effectively measures the mathematical distance between what is being said and what is being shown.
That's wild.
It realizes, wait a minute, the text vector is pointing towards +10 positive, but the face vector is pointing towards -10 negative.
And that conflict, that mathematical discrepancy, that is the sarcasm.
Precisely. It's so cool. And the lecture notes actually mention that the model goes a step further here.
What does it do?
It infers the social context. It deduces that these people are likely close friends.
Oh, because of the social rules of sarcasm.
Right. Statistically speaking, you don't drop that kind of dry, biting sarcasm on a total stranger without starting a fight.
Wow, so the AI is effectively reading social dynamics now.
Yes, it's a form of social intelligence derived entirely from data fusion. And this matters so much because real-world problems are almost never just text.
Right. If you want a robot to navigate a busy hospital or an AI to tutor a child, it has to understand the vibe.
It has to. It has to understand that when a student lets out a huge sigh and says, oh, great, more math,
Yeah.
they aren't actually excited.
Which is the perfect segue to our second topic today, education.
Yes.
Because if there is one place where the text-only chat box fails miserably, it is trying to learn geometry.
Oh, absolutely. The lecture highlights this specific limitation. Text by its nature is linear. You read it one word after another, but geometry is spatial.
It's all about shapes and relationships.
Right. So if you ask a standard text chatbot to explain a complex proof about a circle and an intersecting chord, what do you get back?
You get a massive wall of text. It says, let circle C have radius R and intersect point A at angle, and my eyes just glaze over immediately.
It's arguably the worst possible way to learn a spatial concept. So the MIT materials introduce a fascinating project by researchers Stephen Chen and Jimin Lee.
The Interactive Sketchpad.
Yes.
And reading about this thing, it just sounds so cool. It's basically a digital whiteboard, right? But a whole lot smarter.
It is a whiteboard, but it's a whiteboard they can see. It actively watches you draw.
Okay, so walk me through the user experience here. Say I'm a student, I've got my digital stylus, and I'm staring at a blank screen. What actually happens?
So you draw a circle. The AI sees the pixels, sure, but it instantly converts those pixels into a mathematical object. It knows that is circle C.
Okay.
Then you draw a line straight across it. The AI recognizes that as a chord. You mark an angle and scribble 45 degrees next to it. The AI logs that specific value.
So it's building a model as I draw.
Exactly. It is building a structured representation of your drawing in real time. It's not just looking at a flat JPEG image. It actually understands the geometric relationships.
It knows that this specific line intersects that specific circle at exactly this angle.
Yes. And because it has that deep understanding, you can start asking questions naturally. You can literally point your stylus to a part of your messy drawing and ask, is this right? Or what do I do next here?
And it can answer based on my specific terrible drawing.
It can. It performs what they call visual problem solving. So it might highlight a specific triangle you just drew, literally lighting it up in a different color on your screen and say, look at this isosceles triangle right here. What does that tell you about the base angles?
See, that is the fundamental difference. A normal chatbot just dumps the final answer on you. But this sketchpad gives you a nudge.
It guides you.
Yeah, it feels way less like a search engine and much more like a human tutor actually standing over your shoulder looking at your paper.
That is the grounding aspect the lecture talks about. The AI and the human are grounded in the exact same visual reality.
They're looking at the same thing.
Right. And that shared context is what has been completely missing from EdTech for years. It shifts the entire interaction from just retrieving information to true collaborative thinking.
It's a huge paradigm shift. But I want to pivot now to the third piece of this lecture because honestly, I feel like this is where the rubber really meets the road.
The agents.
The agents. We've talked about AI seeing sarcasm and AI seeing geometry sketches. Now let's talk about AI actually doing things.
The source refers to them as multisensory agents for the web.
Now we hear the term agent thrown around constantly right now. Everyone in tech claims they are building an agent. But what does that word actually mean in the strict context of this MIT research?
In this context, an agent is an AI system built for digital automation. It is not just sitting there generating text for you to read. It is actively using a web browser exactly the way a human does.
So it can click things.
It can click buttons, it can type text into search bars, it can scroll down pages, and it can make independent decisions.
Okay, so instead of me going to Amazon spending 10 minutes looking for earphones, I just tell the agent, go buy me earphones.
In theory, yes. But the lecture slides break down the underlying architecture required to actually pull this off, and it is incredibly complex. It's not just one big brain doing everything. It's a continuous loop.
Let's break that loop down for the listener, because I think people assume it's just magic, but it's a very specific mechanical process. What is the very first step?
Step one is high-level reasoning.
Yeah.
The agent needs a master plan.
Okay.
It has to look at your simple request and say, okay, to buy earphones, I first need to navigate to a retail store, then search for the item, then filter the results, then select the best one, and finally go through checkout.
Which seems simple enough, right? That's
Yeah.
essentially what I do in my head without even thinking about it.
Exactly. But then comes step two, observation parsing. The agent has to look at the screen, literally reading the raw pixels of the web page, and identify where things are.
Like where the search bar is located.
Right. Where is the search bar? Where is the sort by price drop-down menu? And you have to remember, every single website is designed completely differently.
Oh, true. Amazon looks very different than eBay, which looks totally different than Best Buy. So the AI has to dynamically read and understand the unique layout of whatever site it lands on.
It does. And once it figures that out,
Yeah.
we hit step three, which is low-level action generation.
Doing the thing.
Yes. It has to actually send the digital signal to the operating system to move the mouse cursor to coordinates X and Y and execute a left click.
So it is literally driving the computer.
It's in the driver's seat.
Yeah.
But here is where it gets really interesting, and honestly where it often completely fails. The lecture uses a very specific shopping scenario to illustrate this.
The earphone example.
Yes, the prompt is, purchase a set of earphones with at least 4.5 stars in rating and ship it to me.
Okay. I mean, I could do that myself in maybe 30 seconds.
You could, but for an AI, that command is filled with what the lecture calls ambiguity.
Ambiguity. It seems pretty crystal clear to me. 4.5 stars. Earphones. Ship it. What exactly is missing there?
Think about how you shop. Which earphones do you actually want? In-ear or over-ear? What is your actual budget? Are we talking $20 cheap earbuds?
Yeah.
Or $300 noise-canceling studio headphones? Do you care about the brand? If you give an AI what they call a zero-shot command, meaning you just bark the instruction at it once and walk away, it tends to panic.
I really love the idea of an advanced AI just panicking at the Amazon search bar.
It really does, though.
Yeah.
The lecture shows that in a zero-shot scenario, the model might just type the word wireless earphone into the box,
Yeah.
see a list of 5,000 results, and just freeze. It doesn't know how to choose.
Or what, it just buys the first one?
Worse, it might pick the very first sponsored ad it sees, because technically it meets the earphone criteria, even if it's some cheap scam knockoff that's going to break in 2 days.
Right, because it technically fulfilled the prompt. So how do the researchers fix this? Because I definitely don't want my AI buying me garbage scam headphones just because it got overwhelmed.
They solve it using a technique called few-shot high-level planning with human clarification.
Okay, that is a serious mouthful of jargon. What does that actually look like in practice?
Think of it like this. It transforms the AI from being this flawless magic box into a slightly nervous intern.
Okay, I like the nervous intern analogy.
So the agent starts the task. It says, okay, boss, I'm searching for earphones. But then it stops and it pings you. It explicitly asks, hey, do you have a specific price range in mind?
Ah, so it is programmed to admit what it doesn't know.
Exactly. So you reply to it, keep it under $50. The agent updates its internal plan and says, okay, I will sort the results by price low to high, but then it stops again.
It hits another roadblock.
Right. It says, sorting low to high is showing me a bunch of charging cables and replacement ear tips. Should I filter by customer rating first to get rid of the junk?
So it's collaborative planning.
Yes. You and the agent are refining the plan together in real time. The AI is handling all the repetitive clicking and scrolling, the sheer drudgery of the web, but you are providing the critical judgment.
This feels like a very crucial distinction for the future of this tech. We aren't just letting these autonomous agents run wild with our credit cards. We are keeping a firm leash on them.
We absolutely have to. The source material specifically talks about using reinforcement learning to prune bad actions.
Meaning what exactly?
Basically, every single time the human steps in and says, no, don't click that sponsored ad, the AI learns that clicking random ads is a bad long-term strategy. It actually updates its internal policy for the next time it shops.
It really feels like we are rapidly moving into a phase where using AI is going to be less about prompt engineering and way more about middle management.
That is a very real possibility. You stop being a creator and you become the supervisor of a digital workforce.
But this naturally leads us to the darker side of this entire lecture. We've been talking about how great it is when the tech works, but what happens when the tech works perfectly, but it does something we fundamentally didn't intend?
The ethics and safety section. This is so critical because as we move to multimodal, the actual risks are changing form.
The lecture explicitly warns about unimodal biases mutating into multimodal risks. Can you unpack that for us? Because we hear a lot about AI bias in the news, but this feels materially different.
It is entirely different. Look, we all know that text-only models can be biased.
Oh.
If you ask a standard language model to write a fictional story about a doctor, it might default to using he/him pronouns based on outdated training data.
Which is bad, obviously.
It is bad, but ultimately it's just biased words on a screen.
Right, it's biased speech.
Now, I want you to imagine an interactive agent that is executing real actions out in the real world. You say to this agent, find me a new doctor in my area and book an appointment for Tuesday.
Okay.
If that same underlying demographic bias exists in the agent, it might physically filter the search results. It might prioritize clicking on the web profiles of male doctors and actively ignore or scroll past the female doctors.
Whoa. So it's not just saying something sexist anymore, it is doing something sexist.
Yes.
It is actively shaping my real-world economic choices and healthcare choices based on a hidden bias.
Exactly. The lecture explicitly notes this specific risk. They call it gender and generated actions. It effectively hides an entire portion of the available workforce from you simply because of a statistical flaw in its underlying training data.
That is deeply terrifying because it's completely invisible to the user. I would just look at the final list of available doctors the agent gave me, and I'd assume that's everyone available. I wouldn't know who got filtered out.
And that is the true danger of agentic automation. The source material notes that it is very easy to generate biased and dangerous content with language models. But that danger is massively amplified when the AI suddenly have access to a web browser, a calendar, and a credit card.
It's no longer just a chat window answering trivia. It's a literal actor in the economy.
Yes.
So what is the proposed solution here? The lecture talks about needing models that are trustworthy, safe, and controllable.
Controllable is the absolute keyword there. We need that human-in-the-loop dynamic we talked about with the shopping example. We cannot simply hand over full, unverified autonomy to these agents.
We need guardrails.
We need verification steps built into the workflow. We need to be able to accurately predict what the model's going to do before it actually clicks the buy button or the book appointment button.
It sounds like we essentially need to act as the frontal cortex for the AI.
That is a fantastic way to put it. The AI has the motor skills now. It can click and navigate, but we have to provide the executive function, the judgment, the ethics.
So pulling this all together for the listener, we have gone from detecting sarcasm to drawing geometry to shopping for earphones. It feels like the grand common thread running through all of this research is integration.
It is. It's about finally reintegrating artificial intelligence back into the messy complexity of the real human world.
We started with that sarcasm test integrating text and vision to find the actual truth hiding behind a facial expression.
Which is a massive leap in artificial social understanding.
Then we looked at the interactive sketchpad integrating drawing and dialogue to actually teach concepts better.
A leap in human-AI collaboration.
And finally, the agents integrating high-level reasoning with web browsing to just get mundane stuff done.
A leap in daily productivity.
The lecture slides actually list the core opportunities here as productivity, creativity, and well-being. And looking at all this, I can genuinely see that if this tech works the way it's supposed to, it takes so much of the digital drudgery out of our daily lives.
It shops for us. It helps us learn spatial math faster. It navigates the web.
But only if we can actually solve that reliability problem we just talked about.
Right. The guardrails have to be there.
Which brings me to the final thought I want to leave everyone listening with today. We talked a lot about that nervous intern dynamic.
Yes, the few-shot clarification.
Right. The AI asks you for the specific price range, then it pauses and asks you about the brand, and then it pauses again to confirm the shipping address.
It requires management overhead.
Exactly. So here is the paradox I keep thinking about. If the immediate future of AI is us constantly correcting and supervising these digital agents, at what point does the actual management become more work than just doing the task itself?
Ah, the efficiency paradox.
Right. If I have to spend 5 full minutes carefully explaining to my AI exactly how to search for earphones, filtering the results for it, and approving the final purchase flow, I really might as well have just spent the 30 seconds buying them myself.
It's a very valid fear. The ultimate goal, of course, is for that nervous intern to eventually learn your preferences and become a senior employee who doesn't need to ask permission for every little click.
But we clearly aren't there yet.
No, we're definitely in the intern phase right now.
So it's just something to chew on the next time you ask an AI to do something complex and you find yourself having to correct its mistakes 3 times in a row.
Hmm.
Are you actually saving time, or are you just becoming a manager of software?
It really is the defining question of the next decade of tech.
Well, thanks for diving deep with us today into the multimodal future. It's been fascinating.
Always a pleasure to be here.
See you all next time.